Hi everyone, now we are going to learn about file pointers in C. These are special pointers that help us work with the files like opening, reading, writing and moving inside the files. By end of the session, you will know how to use of them and how to handling the files in your programs. Next slide is Introduction to File Pointers. Whenever we work with the files in C, we can't just open files and then start reading or writing directly like we do with the variables. We need just something to act as a connection between our programs and the files. That's where the file pointer comes in. In C, every file is accessed using a special pointers of a type like a file star. Star is represented as a pointer. You can think of this pointer as the handle for the file. Why do we call it a handle? Imagine a door. You never grab the entire door, right? You use the handle to open and close it. Similarly, the file pointer is the handle we use to work with a file. And the another important thing is that the file pointer keeps track of your position in your file. Suppose you are reading a long text, this file pointer knows exactly which word or line you are currently on. Each time you read or write, it moves forward automatically, just like a cursor in a text editor. And the next thing is to make it even a simpler. Think of it like a TV remote. You don't go to the TV screen and press it, right? You use the remote to change the channel and they adjust the volume or pause. The remote doesn't hold the TV program itself, but controls what you see. In the same way, the file pointer doesn't hold the entire file content itself, but controls how your program accesses and manipulates it. Next slide is declaring and using file pointers in C. The first thing we need to do is create something that can represent the file in our program. We do this by declaring a file pointer, the syntax like a file star fp. Here, fp is just a variable that can hold the address of the file, but at this stage it's empty. It's like having a blank remote without batteries, right? To actually connect it into a real file in our computer, we use the functions like fopen. When we call like fp equal to fopen, open parenthesis data.txt comma or data.txt is the file name and R means read mode. It links FP to the file data.txt on disk. From this point on, your program won't talk to the file name anymore. Everything is depending on reading, writing, moving around in the file will happen through this pointer, right? So remember the file name, file pointer in your gateway to the file. Without it, you can't do any read or write operations. Next slide is file pointer movement. Once we have a file pointer connected to a file, something very important happen, right? The pointer doesn't stay in one place, it just automatically moves as you work with the file. The first thing is whenever you read a data, the pointer moves forward with every character or bytes that it is read, right? It's like just reading a book, like your finger moves along with the words as you read them. And the second thing is when you write data, the same thing happens. The pointer moves forward as you add a new informations, just like pen moving along with the page while writing. And the third thing is throughout this process, the pointer is always keeping track of your current position in your file, and then your program is always knows exactly where it is, whether at the start or somewhere at the middle or somewhere at the end, like that. And the fourth thing is if you ever want to read the file again from the beginning, you have to reset the pointer, like otherwise it will stay where it left off and you won't get the whole content. The next slide is functions to manage file pointers. Now we know that file pointers move automatically, right? What if we want to control its position ourselves? C provides some really useful function for this. And the first function is fseek of fp comma offset comma origin. This lets you move the file pointer to any position you want. Offset tells how far to move, and origin tells from beginning, current position, or end. For example, fseek of fp comma 0 comma seek underscore end. This line tells the moves to the pointer straight to the end of the file. And the next one is ftell of fp. This simply tells you the pointer's current position in the file. And it returns a number of that represents the location in bytes. This is really useful when you want to know how much of the file you have read, or even to find the file size. And third one is we have rewind of fp. As the name suggests, it resets the pointer back of very beginning of the file, just like a rewinding of the video. These are the functions are very powerful, and because of they let you negative inside the file instead of just reading or writing from starting to finish. You can jump at any part instantly, which will be very important when working with the big files or records. Thing is example of file pointer movement. The show is simple but very useful example of how to use a file pointer. First we have a fseek of fp comma 0 comma secant. This moves the file pointer straight to the end of the file. Why do we do this? Because at the end the pointer position at the same as the total number of bytes in the file. And the next one is long size equal to ftell of fp. Here ftell checks the pointer just current position and stores in the variable size. This gives us to the size of the files in bytes, it's like asking as where I'm right now, and the answer is how big the file is. And the third one is rewind of fp. This sends the pointers back to the beginning of the file, and so we can start reading or writing from the start again. So this short example does two things, it measures the size of the file, then resets the pointer. These are very common task when dealing with the files, especially in situations like reading a file completely into a memory or showing its file statics. Real world applications in file pointer. File pointer are not just theory, they are just using everywhere in real world applications like softwares. Take database for example. A database files may contain thousands or even millions of records, instead of reading every record one by one, right? The program can use a file pointer and jump straight to the record it needs. It saves a huge amount of time, right? And the next thing is image processing. In this case, files often have headers containing informations like size, color, depth, or format. So we don't always need that header. So we can using the pointer to skip over it and directly reach out the pixel data we need to work with. And the next thing is when we work with the large files logs or data archives, it's very inefficient to read everything sequentially. File pointers let us quickly move to the exact position we need, so making the program much faster. So this main idea is here, good pointer management makes files handling efficient. It returns it turns a slow linear process into something fast and flexible. That's why understanding this concept is essential for any serious programmer. Sliders, let's quickly wrap up everything we learned today about the file pointers. First, remember that the file pointers are the bridge between your files and program. Without them, you cannot open, read, or write anything. And the second thing is they keep track your position while you read or write, just like your bookmark in a book or the cursor in a text editor. And the third thing is we have some very important functions like fseek, ftl, and rewind that gives us full control over the file navigations, moving to the end, checking the size, or jumping back to the start. And the final step is the file pointer are not just for practice, they are crucial real world applications databases, image processing, and working with the large files where based on precision matter. So if you understand the file pointers well, you can handling the any file operations confidently and efficiently. Thank you.